Example 3 says the function is defined as f of x equals negative x plus 2 if x is greater than or equal to negative 1 or to positive 1, and x plus 4 if x is less than 1. So this is the graph that I want to get. When I type this into Desmos just like this, we get two lines that go on forever because this line is going to go down forever. It's got a negative slope, so it's going to go down forever and then go up in this direction forever. And this one is going to have a positive slope, but it's going to go up to the left and down to the right. Nope, down to the left and up to the right forever. So why does this not look like this yet? And it's because we have not restricted that domain like we did on this one here. So this one's kind of a partially done one for you. Once we type this in, we now need to put in the restrictions to that domain. So we'll do squiggly bracket. X is greater than or equal to 1 with our squiggly bracket. And then squiggly bracket when x is less than 1. Okay, and we're noticing that this is breaking at x equals 1 because why? Because that's where it's breaking on its domain. So we have one graph to the left of 1 and one graph to the right of 1. So let's type in our restrictions here. Okay, so we have, so remember if you do x is greater than, then hit the equal symbol, it puts that line under there. And then x is less than 1. Okay, now my graph looks the same. And I mean, really, we're not graphing this by hand. So 90% of this lesson, maybe 80% of this lesson is just, do you know how to type this into my math lab? Okay. Now let's remember it's going to go down in this direction forever. And it's going to go down in this direction forever. So you don't have to include these arrows here, but we do need to remember that this is going infinitely in these two directions. Okay, so find f of 0. You can use the graph, or you can just simply substitute this in. If my x equals 0, is my x greater than or equal to 1 or less than 1? And it is less than 1. So I'm using this x plus 4. So we have 0 plus 4, which will give me 0. Which, if we go to where x is 0, go up to meet your graph, that is what your y value equals. So we can see that from our graph. Then we have f of 3. If I plug it in here, which function are we using? Well, if we have x is 3, that's when x is greater than or equal to 1. So we'll use this negative x plus 2. So negative x plus 2 equals negative 1. So why is my 3 negative? We have a negative x, right? So that's where that negative came from. Okay, and can we see that here? When x is 3, I have no graph above, but down here I do. What is that y value? It is negative 1. Okay, what is the domain? You can look at the graph going left to right, or just look at this domain here. We have every number bigger than 1, equals 1, and less than 1. We are talking about every number, all real numbers. Now, one thing we forgot to do was talk about our open and closed circle. So let's go back up before we finish this video here. One of these needs to be open, the other one needs to be closed. Okay. On my red line here, and this is also why Desmos is so nice since it color coordinates it for us. But on this red line here, this is when x is less than, or sorry, is greater than or equal to 0. Because it's or equals to, this tells me that this red line here is my solid one. Then on the blue line, it is simply less than 1, which means open circle. So that's what my graph looks like. So when you're looking at that domain, negative infinity all the way, oh, it's missing 1, but nope, there is a value at 1, and it's going to keep going forever. So negative to positive infinity, since I have no break right here.